Thanks everybody for coming back after the break. Afternoon session on the last day. Hopefully we can keep it as lively as we've been. So I'll leave it to Aerin to introduce his illustrious panel.
Brilliant. So my name is Aerin Booth. I run a consultancy called Cloud Sustainably, and I guess I started that a couple of years ago after I was the head of cloud at the UK Home Office, and it's kind of been a journey, and why I wanted to bring this panel together is because I'm starting to realise there's so much more we need to talk about when it comes to sustainability. One of the things is just culture change, there's supply change, there's the real world impact, and what I also did was start a podcast, and I've been able to speak to many of these people on my podcast and interact with people, and more, I'm just thinking, okay, how can we continue this conversation? So I guess I will start. I've done my introduction, let's do the others, and then we can kick into it. So,
I'm John Booth, Managing Director of two companies, actually, Carbon Free IT Limited, and I'm also the Technical Director of the Data Centre Academy, and we're very much on the same page as Aerin when it comes to data centres and sustainability, and we provide consultancy and training for that in the near future, we hope, at our site in Rugby, which is actually on a real data centre. So it's as close to a real data centre as you can possibly get, because we'll be emulating software in there and giving the delegates a real data centre experience.
Anne?
My name is Anne Currie. I've been in the tech industry for nearly 30 years now as an engineer and as a startup founder. And I've been working for a couple of years on writing about how to be greener, how to develop more sustainably, how to host more sustainably. And latterly, I have also been a science fiction writer, sci-fi, and book 8 will be coming soon. But there you go.
Hello, I'm Simon Wardley. First of all, I love your sci-fi stuff, by the way. So I used to work in the environmental field back in the 1990s, when we could have actually done something. I was involved in cloud between 2006 and 2012. I sort of retired from cloud back then. I do something called mapping, which is used all over in lots of different interesting places. And I have a particular focus at the moment on supply chain. So I think that's why Aerin has dragged me along here today. So absolute delight and thank you.
Well, thank you so much for everyone for joining us. And to continue what I was saying earlier in terms of, what do we actually need to do to solve this problem? We need to accelerate it further. We need more people to start caring about climate change and realising it's a problem. So many of us in tech look at new technology as something just to consume or use or play with. We're seeing AI and ChatGPT and all these other things. I think, Microsoft announced today that AI ChatGPT is going to be integrated directly into Bing. So if you think previously there was a carbon cost of a search online, now there's going to be a carbon cost of a search and a machine learning algorithm being run online, and that's just increasing our emissions. And for this panel, and I'll start with Anne's side really, because we need to think more about, is it ethical? And one of the things I really loved about Anne's books, I came across them after we spoke on the podcast, and I was like, oh, I should have read these beforehand, maybe I will. And then I read 2 of them, and then I read 5 of them in 24 hours. And I was like, hey, Anne, I really like your books. And Anne said Amazon actually sent her a direct email, because that's where they are. And they're like, oh, you've got a new record. Someone's just read 5 books in 24 hours. And yeah, I think one of the kind of really interesting things I was impacted by was, is it sustainable if it can't scale? And
yeah, it's yes, it's certainly scalability is completely it's both the potential saviour and the destroyer of the planet. In that, if it's unsustainable and you attempt to scale it, just burn up huge amounts. It's hugely destructive. But if something is massively scalable, it's worth investing in making it very much more efficient. So. For example, the cloud is much more efficient, generally, vastly more efficient than on-prem data centers in terms of amount of per job done, per unit of work done, because they're intended to scale, they're planned to scale, and it costs them a huge amount of money if they are inefficient when it comes to either hardware use or energy use. So the cloud, yeah. Scale has good sides and bad sides, as with anything. Scale depends how you use it, doesn't it, really?
Well, that's it, isn't it? It's about like, when we think about sustainability, it's more than just carbon. There's so many other elements that come into whether it's good for the world. Is it giving us more access to food? Is it helping us with water? Like, what's the environmental impact elsewhere, such as chemical runoff? And that's the sort of thing which I really wants to bring to this course is, what are those other impacts, and how do we understand the landscape we operate in? So Simon obviously mentioned Wardley mapping. Maybe touch on some of the points we have been researching.
Gosh, you've actually thrown a whole sort of spanner in there. One thing we've got to do is break down the concept of sustainability. But before we get there, I just want to quickly talk about energy. How many of you are familiar with my form of mapping at all? Anybody? Right, super. So for those not familiar, if there's supply and demand competition, any form of competition, whether it's conflict, collaboration, cooperation, things will tend to evolve. They're diffused through multiple waves, but they'll also evolve. And they'll go from the genesis of the novel and new, then you'll get custom-built examples, products, and eventually commodity and utility services. So if you think about radio, you'll get the first ever radio, crystal-built radio sets, then my radio is better than yours as we get products. And then we'll forget about radio and we'll just talk about what's on the radio. We'll have the radio times. It'll become more of a commodity. Now, one of the things that happens is as things evolve, they enable us to build higher order systems, what we call the adjacent unexplored. So when compute became more of a utility, suddenly we could do all these new wonderful things. So we could do much more video streaming. We get companies like Netflix. We eventually could do things like large language models. And eventually those become a commodity and enable new higher order systems. So what's going on in the system is we're ever moving towards higher, more ordered systems, and that requires energy. Always energy. So the first thing to bear in mind is that whatever we do, people talk about we need to be more efficient. For society to progress, you're going to need more energy. Ultimately, it boils down to the mechanism by which you generate energy. There's only so far you can get with efficiency. Eventually you'll do more stuff, and that's Jevons paradox. Right, so that's the first problem. Lots of people like to think we can make ourselves more efficient out of this. Eventually time will overrun us. The second problem is, what do we mean by sustainability? So there's two aspects. There's the impact, as in, when I take this activity, how much does it impact others? Maybe because it's rivalrous, only certain people can do this. How much does it impact the environment we operate in? And the second aspect of sustainability is how resilient this thing is. So can we be excluded? Is there some sort of constraint within it? Is there security weaknesses within it? So those both are important aspects to the sustainability of something. Now, if I look at something like the retail industry, as I mentioned this, I was on a retail site yesterday looking at impact, and it's wonderful. They had this picture of a hoodie, because I was looking at buying my wee lad a hoodie, and it said 5.86 kilograms of CO2. And I thought, wow, what a very accurate figure for the impact. Isn't that great? So then I looked at a pair of socks, and I thought, what's the CO2 for that? And it said 5.86 kilograms of CO2 for a pair of socks. And then, okay, and there was a duffel bag, and that's 5.86 kilograms of CO2. That's right, every single product in this retail site was 5.86 kilograms, even though they specified it's to the product. So why? How is this going on? Well, it's fairly simple. There's a long, complex supply chain of they get their stuff from various API vendors providing data against products, and they get their stuff from database vendors, and they get their stuff from consultants. So there's a long chain of people working on averages. So you end up with this ridiculous average figure at the end because nobody understands the actual supply chain by which things are constructed. And that is one of the biggest problems that we have from a point of view of sustainability. But it's also the biggest problem we have from the point of view of resilience. So, for example, who knows who Leone is? Anybody? Probably not. They make basically cable harnesses used in automotives. They've got a problem because of the Ukraine-Russian conflict. Their factories are closed down. Because of that, they can't provide cable harnesses to automotive companies who are suffering from supply chain issues with silicon So they can't manufacture as many cars. So we're not getting as many dashboards, which means we need less leather, which means we get less gelatin, which means you get less gummy bears. So we have these wonderfully long, complex relationships where things over here are impacting things over here. And we see this in the world of IT, whether we're talking about supply chain attacks, solar winds in terms of the digital software, and it's good to see Biden doing that executive order saying at least have bill of materials. It's not far, but it's at least a starting point. We also get both these impacts in the physical world as well. So when it comes to sustainability, you've got to think about the impact and the resilience of what you've got. And in both cases, unfortunately, we have atrocious levels of supply chain awareness, which is causing the weaknesses that we're seeing in the system today.
Yeah, I mean, those weaknesses and some of the stuff that, you know, Simon's obviously very familiar with. One of the things he shared with me is antimony is one of the things that is basically manufactured by Russia, or that's where it's mined. That's
China and Russia.
In China and Russia. And, you know, as we enter into the war in Ukraine, and antimony goes into armor-piercing bullets.
Yeah.
And that's the sort of thing is like, you know, sustainability in terms of those impacts. And it's like, okay, is it sustainable to have a year's end war with the aggressors who control your supply to your weapons or whatever else? And that's the sort of thing where it's like all of these second order, third order sort of relationships exist in so many different things, but they definitely exist in cloud. And the reason why I kind of obviously asked John to join is we talked about energy, but there's other elements of what goes into a data center, and you're probably the expert to go through that.
Yeah, so obviously the first is location. Where do you put your data center? And that needs to have three elements. It needs to have energy, or access to energy. It needs to have comms, access to fibre cables, and it needs to have people, right? And I think there's a big problem at the moment with people going to the Nordics. Right? Mm-hmm. So we've heard all these wonderful stories. I mean, Panorama show that was on Monday, I actually went to a data centre in Norway, in Stavanger, in a former NATO base. Now, that is 100 kilometres from Stavanger, right? And it's not an easy place to get to. If it's not an easy place to get to, it's not an easy place to staff. And staff are key to the functional operation of a data centre. You can do robotics as much as you like, but you know, at the end of the day, there needs to be somebody with boots on the ground actually mooching around this data centre. So those three elements, first of all. And that data centre was very lucky because they used a former NATO missile silo, right? So the infrastructure was already done. If you wanted to build a brand new data centre, you're looking at vast amounts of steel for the superstructure. You're looking at loads of concrete for the base element, and then the panels, which are usually composite panels. So there are multiple composites of materials, which are very difficult to shred and reuse. And that's just the building itself. Then you think about all of the electrical infrastructure, right? So you've got your switchgear, you've got cables, you've got all sorts of wonderful stuff in the low voltage and medium voltage chain to get the power to the actual servers itself. Then you have the cooling infrastructure, chillers, ducting, piping. Then, maybe your cooling solution might leak. So we better put a leak detection system in it. And they generate quite a lot of heat, so we need to put some fire detection and some suppression equipment in. So you're looking at very early smoke detection apparatus and fire suppression equipment, bottles of whatever fire suppressant you wish to use. You don't want to use water, because obviously that will damage the electronics. I personally feel that any form of suppression is going to damage the electronics, so it doesn't really matter which one you use. But hey, and it was interesting, I was looking at a blog yesterday, and to my mind, the data center industry has stagnated, right, in terms of its design and operations, probably since 1977. So I went to visit an IBM data center near where I live that was built in 1977 and had a cooling tower, right? Now these are pitched as being relatively new, right? But they were there in 1977. I also looked at a brand new data center that was being built out of Farnborough about 2 years ago, and I have seen other new ones since. You can walk down the same corridor and you wouldn't know that you'd moved forward 50 years in terms of the design architecture. We are late to the party in terms of sustainability. Right? But this is very much, I feel, somebody else's problem, right? Most of the senior people that are in charge of the design and operation of data centers are reaching a certain age. I'll say that they're 58 plus one. until 65. And all they're looking at is, you know what, I'm an old dog. I don't want to learn a new trick about sustainable data centers. What I want to do is just to see out my last remaining years and then retire and go onto the veranda smoking a pipe, drinking red wine. Mm-hmm. So they're leaving the problem to the young upcoming ones. But invariably in the data center industry, and I've seen it myself, they have a standard design. And they'll get a client inquiry maybe 10 years later, and they'll whip that design out, put it down, scrub out the name of the previous client, put the new client's name in, and present that and say £200,000, please. Right? And this blog that I was reading yesterday was saying, you know, they are writing basis of design documents for data centers because most data center people who are seeking to procure them are technically aware. So they're writing specification documents, which leaves nothing for the designer, no maneuver, right? No space for innovation, no space for looking to the future, no space about thinking sustainable. So the design stagnates.
Can I ask you, are you not calling the death of the data center industry there from stagnation, given the fact, unless you are a massive scale player, so if you're just a mum and pup investment bank or some, you know, corner shop, supermarket or something like that, you know, you're a Sainsbury's or a Tesco's or somebody, you shouldn't have a data center. I mean, it doesn't make sense, does it? It only really makes sense for the super hyperscalers because they'll understand the supply chain. They'll understand they have a chance of doing this. They have a chance of providing sustainably. Are you not just calling death on the industry?
I'm not calling
You're efficient, even if you don't like it.
So Simon, I'm not calling the death of the industry. What I am saying is, you know, where did the UK kind of standard data center philosophy come from? And it came largely from the 1980s when the American banks moved into the city, and there was no data center standards, right? And there was a fear of all of the risk profile that they had in the US because of the way that the US operates was brought over to the UK, and these risks don't exist in the UK at all, right? And yet we've designed our data centers for these risks from the US. Right? And this is in terms of electrical infrastructure. Right? So in the US, the electrical grid in certain states and cities is very flaky because there is no national grid. Right? In the UK, we have a national grid. If one power station goes offline, you're not going to see any impact because another one will come up, or there'll be a limited outage. But in the US, they assume that their power station is going to be offline for weeks. So they build this island mentality. And as John said in his open hardware discussion earlier, you've got backup generators and UPSs and all this sort of stuff for a risk that largely doesn't exist.
I mean, you've said so many interesting things, but you've mentioned requirements, and that's one of the things I find kind of like linking these two worlds together is really important. The next generation of cloud education, we need to think about requirements differently. Because right now, if you look at kind of Amazon, the cloud providers, they'll say security is job zero. You know, you choose your requirements based off how secure it is, how resilient you want it, and how often you want to access it. And when you make those priorities and you say, I want 5 nines because that's what the book said, and that's what that said because of someone else, I just wonder, what can we do to view those requirements through a lens of sustainability?
Yeah, so, I mean, the first thing to consider there is actually what is your risk appetite for your IT, right? Now, I remember doing this, installing mini UPS systems in server rooms. And I always used to think, why are we putting these UPSs in, right? And it was basically, if in the event of a power cut, these UPSs will provide enough power and send a signal to the server to invoke a graceful shutdown procedure, right? So all of the services that run in the server would shut down, and then the box would physically shut down, right? Waiting for somebody else to come back in once the power had been restored and press the button again, right? Because I feel if there's a power cut to a building, then nobody's be able to work because all the computers will be out as well. But it's all right for your server room to be humming away, providing service for people that can't access it, right? So it's a completely pointless exercise to do that, right?
Yeah, in the old days, I'd say our UPS would quite often be the cause of our outages.
Indeed. So it's down to what actually happens in a disaster situation, right? If the power goes off to a city block and you keep all your data centers running on backup services, why are you doing that, because nobody would be able to access it because their physical equipment that they're using to attach to your network cannot be powered because the power's out. Right? I used to work for BT, and I remember sitting in St Botolph's Exchange, which is on the Aldgate Way system, which is an old telex exchange, right? And I was sitting there one day, and when usually, I mean, my ears are affected by it now, but the old click-clack of Strowger equipment, and it was incessant. It was a low buzz everywhere. One lunchtime, you could hear it start to go, right? And then there was silence. And I was like, I looked at my T1 and I said, what's happened? And he went, power cut in the city. Because telex machines were powered by the city offices. And it was their power that was powering the BT exchange.
I'm going to throw in a couple of things here, because you've said about electricity in the UK, and we don't have a central electricity generating board anymore. We've got capacity issues that we know. It's not only just balancing supply and demand, it's leading current, leading voltage issues. And we're cutting down on certain types of generators, which reduces inertia, physical mass, spinning disks, which creates resilience within the system. There's an awful lot of issues going on with the electricity grid, which you're familiar with as well. And I'm going to say, why on earth, in a world of, serverless, where we're heading towards a world of conversational programming, would I ever thinking about containers, Kubernetes, let alone hardware, let alone data centers, unless I'm a massive player? If I was going to give you 100 million and you came up to me and said, you're going to spend it all on building a data center, how am I going to react?
Well, I think you'd be a little disappointed with me. I would be a little disappointed with myself.
I think you would as well.
But yeah, I mean, as you say, you were a big fan of serverless, and actually that's, well, something you said earlier was that efficiency doesn't get us all the way in terms of sustainability. You also need energy, and I agree. In the long run, we are going to need energy.
More energy.
Growth requires energy, and growth isn't always about, growth is kids go to school, and old folk don't freeze to death in their homes and things like that. That requires energy. At the moment, we have the types of energy that seem to be on the ascendant are wind and solar. And nuclear one day will have that, but that's still probably quite a long way off. And batteries, great, but they still cost a lot. It costs a hell of a lot to store energy that's produced. You're much better off using it as it's produced, vastly, vastly better off. And that is the difference. Solar, wind, we need to have things that are not on demand. Therefore, the systems that we build, if they are utterly on demand, they're conflicting with how we're going to have loads of energy in the future.
There are, of course, not just chemical storage in terms of battery.
Well, that's true.
You've got potential storage in terms of hydro.
It's true, but it's very energy undense compared to coal, compared to petrol, compared to
Well, I was going to. There are good points there, right? So we're currently looking at microgrids, right? So, and I think the problem we have, right? Actually, it's a problem from the past, right? So when old Swan developed his electric light bulb, and all the guys that were at the forefront of electricity, there was an old the guy that was in Hogwarts, the father of the Rupert and all those guys. He did a What Happened in the Industrial show that I used to watch, and apparently, when one of the scientists, the electrical scientists, spoke to the government about the rollout of electricity, he said, eventually you can tax it. But up until that point, most electricity production was very, very local. And what we've done is we've centralised, right, into big power stations, littered the landscape with high tension pylons across areas of natural beauty. And now what we're seeing is a kind of return to that. We're looking at microgrids a little bit more in focus now. And data centers should do the same thing, right? So something's called software-defined data centers. So we create all of these ultra-resilient data centers with multiple systems for backup because we consider the data to be king. And it's only one instance of that data, right? But if we follow the Amazon view and the availability zones, and we do 3 data centers, and we have 3 different pieces of the same data residing in 3 different locations, then you can just strip out all of that additional stuff.
Why would I? If I'm building something for someone else, why put it's a bit like if I'm building a taxi firm, why worry about how to manufacture tyres? I just buy the tyres that I need, or I rent the cars that I need. It's where I should focus. So why in today's age? I first of all agree with microgrids, but we've got a big whole issue in terms of control systems.
I agree.
Yeah.
Well, there's number one. How can we get more microgrids?
That's a different issue, because we've got a whole issue about control systems and how we've designed the grid and all the rest of it. But in terms of data center, why bother?
But maybe we should be defining what microgrids are, because we've all said, oh, you'll agree with microgrids. We might want to.
Well, hopefully I can try. But yeah, I guess it's about like looking at how we consume energy differently. Today we rely on the national grid, but we want to link up our homes to individual power generation. We might have batteries that charge our car, or even cars themselves that can push energy back into the home, and then vehicle to grid, and then having that localized communities. And one of the things I wanted to say before is like linking in serverless. It's like, okay, when we think about how we should build services, and a lot of the time we prioritize speed or what we already know, and we end up containers and VMs, and we just throw what we've already got online, but we're not really rethinking how to do this in a serverless way. And that's really important for the future, especially with Anne mentioning sort of more renewable energy on the way. Is this energy we have demand peaks in terms of the country, and we have to control the energy that comes out of these power sources. So with wind energy in particular, we slow those wind turbines down before it can get into the grid, especially when it's high demand. And the interesting thing about the clouds is if everything can be in terms of that serverless workloads, and it's resilient in terms of it can be run whenever you want it to be, that can be a solution to that, is in terms of you have these data centers attached to renewable energy, which would peak demand, especially for machine learning.
Why am I caring? Because if I'm writing in serverless, I mean, you're going to get Amazon eventually, because we've already got billing per function, so it won't be long before they have CO2 per function.
Say that.
Actually, you say that, right? So we have done a very...
Hang on.
Okay.
It won't be long, okay? We can argue over how many years, but not whether it's going to happen. But then the issue is, even with serverless, we're starting to look at prompt engineering. So it's even to the point of, I'm using large language models to help me connect services together. We saw an example of that at AWS reInvent with Jenkins back in 2018. I'm confused as to why do I fundamentally care anymore about data centers?
Well, as individuals, I think for me, why we go into understanding data centers is we have to understand the impact of what we build and how much data we store. For example, we're at a conference talking about open data, open source software, and open hardware. A lot of the time, the conversation in the past has definitely been around the software and the data. If we look at our trajectory of growth of data, we're expected to grow 25% year on year. And some estimates say, or there was a research piece that I came across that said, if we continue to grow with the amount of data that we want to own and store and consume, we'll need to mine a Mount Everest worth of materials just to store it each year.
Yeah, so I've got 2 points, one for Simon and one generally, right? So I was at the QE2 Centre just before Christmas, and there was a girl from the JET laboratory, right? So the Joint European Torus and Fusion. And she said that for the world to meet its 2050 net zero goals, right, we would have to build a power station every day from then until 2050, right? And that's clearly not going to happen, right? So, but coming back onto your element, Simon. So earlier you discussed the various hierarchies of stuff in your mapping, and you get to these high order systems, right? So let's assume that Bugatti Veyron, right, is the ultimate pinnacle of your high order system, right? A fantastic engineered motor car that can travel at exceptional speeds, right? Unless you look at the data center, right? Or in this case, the road that the Bugatti Veyron is running on, you are not going to get to achieve the speeds, because you're not going to get those speeds on a country road. You're not going to get the speeds that you require in the higher end of the cloud unless you have a robust, secure, energy efficient and sustainable data center platform for it all to run on.
I keep on coming back to if I gave Anne 100 million and Anne said, I'm going to spend it all on a data centre.
What would you actually
it would be
do,
like,
though, and what would you build with 100 million?
What would I do?
Yes.
The data center of my dreams.
Oh, no, what do you think we need to spend 100 million
I'll tell you what I
on?
would do. I would buy 10,000 1 megawatt edge data centers and put a mesh network in.
Yeah.
That's what I would do.
I mean, that's really fascinating. I think for me, and part of the reason why I'm doing this is how can we affect culture change in technology? 100 million, where we change the minds of so many different people to be more efficient, care more, do things differently.
But it's interesting. Would I spend it on education, or would I? Because I'm immediately thinking, because I've been switched slightly to your microgrids point. So one of the things that we can do that's very efficient is we don't really want to be using loads and loads of giant batteries within the grid. But batteries in homes can be very efficient, paired with filling them up when there's a surplus of energy available, because you don't want to have to turn off your wind turbines or even your solar panels. A range of house batteries across the UK would massively stabilise the grid. And it feeds into that kind of microgrid way of working, where actually the energy stays closer to where it is, and batteries are getting cheaper and cheaper. So I might be looking at something like that, except that there aren't any batteries to buy because of supply chains.
I know, but I love this. So Anne's promoting here, we're going to build a business which does batteries at the home. Love that idea. But if you turn around and said, I'm going to spend 90 million building a data centre rather than using Amazon or something,
it's just
crazy. It'd be crazy.
What would you spend 100 million on, Simon?
I certainly wouldn't be building a data centre.
Okay, so you say that, right?
Unless I'm
Amazon, right?
Unless I'm Amazon.
Do you know how much a 100 megawatt Amazon data center would cost?
I have no idea.
1.5 billion.
Okay, great. That's.
So why should they spend it?
Why should they?
Why should they invest that money in? None of them have made a profit. No cloud company has made a profit for the last 10 years. The hyperscalers, right? Amazon lost 3 billion last year, which is 2 of their data centers.
So, really interesting conversation, and I love it all, and I'm just conscious of time. The one thing I would say, if we just click the slide for me, this is the sort of thing we want to look at in terms of education and conversation and getting people to speak directly to experts like this to go, okay, what do we need to do? What do we need to do differently? And we are together doing a online course. It's a 3-week cohort-based course designed for executives, filled with workshops and, I guess, something special from each person that's involved, and hopefully that's the sort of thing where people who are in the decision-making powers, policymakers, experts, politicians, and executives in businesses can go, okay, what should I start caring about? But we've said a lot today. We've covered loads of different things. Who's got the questions for us so we can actually help you with understanding more of this?
I have a question.
Just wait for the microphone, yeah.
Hi, I'm Mike, and I was intrigued by your panel heading. So my question is then, well, actually, who are the disruptors transforming the next generation of our future data centres with this efficiency and sustainability? And do we have endless natural resources where we can build 65 million batteries that will go in all of our homes in the UK? There has to be some ROI, and the resources will eventually expire.
Mm-hmm. I mean, that's a very good question, actually. So, as I said earlier, we're working with the largest data center construction project in Europe at the moment, which is just shade under 500 megawatts of IT load in Portugal. And they have got 5 gigawatts of solar, right, to support that. They haven't got interestingly enough, they haven't looked at a battery solution yet, right? But they are using some innovative seawater cooling. So they're located next to the LNG terminal for Portugal. So they're bringing in all of the gas, natural gas from America and Mexico, etc. And they use ocean seawater to cool the liquid LNG so it can be put through the pipelines. And the data center is actually using the outflow of that now super cooled water to cool the data center. This is one thing. But I said earlier about somebody else's problem field, right? There is a massive engineering consultancy, global engineering consultancy, that's helping them build this, right? Because it is the largest one. And when I suggested a few things, so I suggested the use of hemp, as an industrial hemp, as a replacement for some of the panels inside the data center. And they kind of looked at me as if I'd said, I want you to start up a cannabis farm. and I just thought, and I've done some research on hemp, right? And it really is a magic bullet when you think about it, right? Because you can plant hemp on an old industrial site and it will literally pull up the contaminants from the site and it can reclaim a former chemical works in 3 years, right? This is the sort of stuff that this can do. Then when you look at the actual hemp itself, you can make it into all sorts of different things. You can see soaps, you can do clothing, you can make these panels, it can be insulants, it can be corrugated roofing, right? It is a wonder product, and yet the major consultancies are not even considering it. And bearing in mind that a lot of the US states have now released it for medical marijuana and recreational marijuana, so there is lots of plantations going on, and you cannot transport waste products across state lines. What's happening is inside states, they are using hemp as building materials.
Just in conscious of time, go on.
Can you just use the mic so that it's part of the stream?
I completely agree with you, John. Hemp is a magical material.
Yeah.
So why aren't attitudes changed towards it then? And how do you change the
I think we'll
attitudes?
take that-
You're
we'll take that outside.
all the experts. How do we do that?
Yeah, why don't we
Take that
move?
outside.
Yeah, why don't we take another
Please,
question?
I'm the host, and thank you, Eric, for helping. One thing I would say is I released a podcast recently called The Infinite Cloud is a Fantasy, and that was from a researcher called Steven Gonzalez, who calls himself a cloud anthropologist. And one of the fascinating things we talked about then, we've talked about the role of Amazon and data centers and what we prioritize and what our things are. One of the fascinating things is, where do tax breaks exist? And where do we see data centers? And that's the sort of thing when we prioritize things and why we do innovation, a lot of it revolves around just the way we do things now, how much money I want to make, rather than these other innovative questions. Some of the interesting things I found in cloud is go on, Anne.
I'll just add something about something that you said earlier, and then you were asking about the innovations in data centers. One of the places in the world where there is most totally on-demand, constant, free energy is Greenland. Because water is melting off the ice caps, and it always has, but it's even more now than it has been in the past. But there's no one there to do. There's no skills there. There's nothing there to build this stuff. So there's a huge amount of potential resource there that is not being used at all because of the lack of the infrastructure around it and the people.
And this is one of the reasons we created the Academy, because we want to educate people into, and it's the National Data Center Academy, and we're looking at it in two ways, right? We're saying, right, this is how we build them now, right? So this is when you walk onto a data center site, this is what you will see. Mm-hmm. But really, what you want to be looking at is this, which are multiple input sources from energy, right? So bringing in the concept of microgrids, then using the waste heat, right? And you can use the waste heat for other products, right? So we've seen this in Norway already. There is a lobster farm, right? Because apparently lobsters have fun between 20 and 22 degrees, which happens to be the temperature of the outlet water from a data center, right? So they've created this lobster hatchery. There's also a fish farm, which the same thing happens. The fish get frisky at that sort of temperature as well. So they're doing all this sort of stuff. And this is farmed food, right? But then there's, we were in Mauritius, we were looking at the immersed compute product. And you can fix dyes at 40 degrees, right? So when the output of the data center is heat is at 40 degrees, which it can be from immersed, you've got natural, and so they don't have to create water that's 40 degrees. They've got it through a secondary process. Cleaning materials for food prep, right?
Just conscious of keeping to questions. We'll have time for one
I've
more.
got to say, from contaminated hemp to frisky lobsters, I mean, those are some pretty interesting arguments for the data center industry. I've got to say, with limited constraints and resources and materials, there's going to have to be a concentration of effort. I think the greatest innovators in this space are almost certainly going to be Amazon, Microsoft, and Google. For me, the biggest issue is whether they should be nationalized in some way or not, because actually it should be basically a industrialized service. And maybe, when we talk about nationalization, it should be on a global scale. You're seeing this in China. We're certainly not doing this in Western countries, but I would, I struggle to see the advantage of everybody homegrown.
30 seconds.
Very quickly before we finish, but I am a proponent of what you said, right? And I would say that data centers need to be considered to be the fourth utility, right? They need to be regulated the same way as electricity, water, and gas are. But they would scream at that. But actually, what's happening is at EU level, this legislation is coming in under the back door, right? But they are going to be heavily regulated, probably from 2025 onwards.
We've seen it elsewhere. I think Simon was going to say China. I mean, China basically said, you can do cloud in our country, but we own the data centers and you can run your software on top. And that's the power that we can have with regulation if they want to access a market. And more individual countries should be turning around with regulations and say, run the cloud, but here's our lines, here's the things we need for a future.
When things become common infrastructure, that is, so it's interesting because when we talk about economic systems, market system versus centrally planned, market systems are very good for the genesis of the novel and new. They're pretty good for product development. But when you get to the point of common infrastructure, this is actually where nationalisation, heavy regulation, and much more central planning. And we miss this. CEGB, for example, is a big loss.
And it would be lovely, I agree with you, but I can't get it, but moving
our relationship.
It can't get in the way of us actually moving forward because it could take decades.
Yes, that's true.
It's interesting because I run a podcast and now you're saying we should have nationalised and utility-based cloud. The podcast is called Public Cloud for Public Good. And if we thought about what we could do with a publicly owned data center service or 100 million or whatever it is, countries could go, it's a utility that, or even governments or EU, we just say.
I think that's inevitable, Aerin, to be honest. I mean, we're already seeing, John spoke about moratoriums in his panel session. People are reacting. They don't want data centers being built in backyards. So we've got Dublin's got a moratorium, Singapore had a moratorium, Amsterdam's got a moratorium. So these facilities, in order to maintain our online world, right, we need data centers. So it really depends on where they go and what we do with them.
Differently. Well, thank you everyone today. It's been a really interesting panel, and I'm just conscious I'm either going to have to put our slots in the course for much longer, or avoid some people talking for too much. But it's so fascinating. Sorry. No, I don't mean that. I do wonder how we bottle it, how we capture it, how we focus these things, and how we really go, here's some of the real stuff. And well, it's been so fascinating, amazing, and I've had so much fun and learnt about hemp, lobsters, and so many different things. And thank you so much, everyone. It's been great.
Pleasure.
Thank you.
Good to see you.